Okay, here's the last part of algebra. This is kind of the harder stuff, if you remember. Not this first part, but second part is a little bit the linear programming. So this is the revenue, cost, profit stuff. So remember, you're going to have to write the revenue function. Revenue is the money you're bringing in, and the cost is obviously how much it's going to cost you to make this stuff. So look for the key words. Here it says the cost is $5,000, so that's just up front. Whether you're going to make one bike or whether you're going to make 100 bikes, you're going to pay $5,000. And there's another cost word for $40 every single bike. So if it's 2 bikes, it'd be 40 times 2. If it's 3 bikes, it's 40 times 3. So the cost is going to be $5,000 plus $40 per bike. So I'm going to multiply by X because we don't know how many bikes there are. Okay, but you're going to turn around and sell the bike for $60 each. So again, you get $60 for every single bike you sell. We don't know how many you're going to sell. This is the money coming in. Revenue is the money coming in. So that's going to be 60 times every single bike you sell. So the profit is going to be how much money you bring in minus your cost. So it's always going to be revenue minus cost. So your revenue is 60x. Your cost, make sure you subtract the whole thing, so it's got to be in parentheses. And that's your profit. And your break-even point is either you can think of it as when your profit equals 0, or you can just think of it as when revenue equals your cost. So I'm just going to equal that revenue equal to the cost. And then I'm going to do my algebra and solve. So I have to get the x's all to one side. So I will subtract 40x each side. So I get 20x over here, 5,000 over here. Divide by 20, and I'm going to get 250. So remember, x equals 250, but 250 is the number of bikes. So when I sell 250 bikes, I break even. What is the amount of money that I just broke even on, meaning my revenue is equal to my cost? So I have to take that 250 and either plug it into your cost or your revenue. It's the same amount. I would probably just plug it in here into your revenue because it's easier, and you get 15,000. So when do you start making money? You start making money after you sell 250 bikes. More than 250 bikes. So when you sell 251, that 250 first bike, woohoo, you're making money. Okay, so I'll let you go ahead and try number 2 using the answer key and seeing if you can solve it from there. Substitution and elimination. So let's go ahead and do this one here. It says x equals y minus 5. So I'm going to take this x out, and I'm going to replace it with that y minus 5. So what I'm going to do is I'm going to rewrite this second equation. But instead of writing 3x, I'm going to replace this x. So I'm going to erase it, and I'm going to replace it with y minus 5. I keep writing the equation. Minus 4y equals negative 18. So look at this, says 3x minus 4y equals negative 18. Then you distribute the 3. Combine like terms, so we get negative y. We're going to get negative y here equal to negative 3 after I add over the 15. So I'm kind of skipping some steps here. So I get y equal to 3. Remember, y is the second part of my ordered pair, so I'm going to write it like that. So I still have to get the x value. I can plug that 3 into either one of these equations, but it's probably the easiest just to plug it in here because I've already got x equals. So x equals 3 minus 5 instead of y minus 5. So x is negative 2. Just make sure when you're using substitution, whatever you substitute in this case the y minus 5, you always put it in parentheses. Okay, so I'll leave the first one there for you to do on your own. Elimination. Remember, with elimination, we're trying to do exactly that. We're trying to eliminate a variable. Eliminate a variable rather than substitution. So I'm going to do this one here. So I'm going to try to eliminate either the x's or the y's. I'm going to pick the x's. So when I look, I have a 5 and a 2. If I add them together right now, I get 7x. That's not going to eliminate them. I need them to be the exact same number and opposite signs. So what I'm going to do is I'm going to multiply this equation by -2, which that will give me here a -10, which means I need a -10 here. So, I need a +10 because I want to eliminate them. -10x plus +10x, that's 0. That will eliminate the x's, so I need this to be a +10. So I'm going to multiply this equation by 5. And when I say multiply, you're multiplying every single term. So I'm going to multiply each one here. So -2 times the 5x is -10x. -2 and the 4y gives me -8y. And then also the -7 I have to multiply by. 2 negatives make a positive. So then I do the same thing here across the bottom. Now I can see that when I add these equations together, so I'm going to add the equations together, I'm going to eliminate the x's. -10x and 10x, they're eliminated. I continue to add. -8y and 25y is a +17. And over here I get 34. So I eliminated the x's, so now I can just solve for y. Y equals 2. So again, I'm going to put that in the second spot. Now this one isn't as easy to plug it back in. Just pick one of the equations. It doesn't matter where you plug it in and solve for x. You end up with -3. I'll let you finish that out and see if you can do that. Okay, so that's substitution and elimination. So linear programming. Remember, you have your objective function. What we're trying to do is either maximize or minimize. So what we're going to do is we're going to take each of these ordered pairs and you're plugging that in to the objective function. Okay, so I'm not going to do this whole thing just to save time on the video. I'm going to allow you to refer to the answer key. But for example, if I just take the first ordered pair 0, 6, that means x is 0, y is 6, and I'm taking that and I'm plugging it into this equation. So z is going to equal 4 times 0 plus 5 times 6. So that's where the 30 comes from. I'm plugging each one of those in. So you list all of those out, and I would list each ordered pair, just like I did in the answer key, plug it into the objective function. You find your biggest number, that's your maximum. Find the smallest number, that's your minimum. Okay, that's also a good time for that stow button. Those of you that know that stow button and have used it in the graphing calculator before. For example, I would stow 0 in for x. I would stow y in for 6. I would stow 6 in for x. And then I would just plug in the calculator 4x plus 5y, and it's going to spit out 30. So if you remember how to do that. Otherwise, yep, got to do it a little bit by hand a little bit. Okay, so each of those ordered pairs. Again, refer to the answer key. This one is a full linear programming. So you've got Carl the Clown here. He's making balloon animals. He's told he must have at least 35 orange balloons. You can continue to read that. If you remember, we always want to get that objective function first. And I always say, show me the money. Where is the money? That's going to be our objective function. Because what are we doing? We're maximizing profit. We're maximizing our money. So we're going to do $3 for every orange. So X is going to be my orange balloons, the number of orange balloons I get. And Y is going to be the number of blue balloons I get. I always write the objective function first. Now I go backwards. He's told he must make at least 35 orange balloons. At least 35. Can he make 34? No. Can he make 35? Yes. Can he make 36? Yes. You want at least, so it's greater than or equal to. Don't see the word least and think less than. He has to make at least 50 balloons, and he can't make any more than 200 balloons. So the total balloons, total X plus Y, can't be greater than 200. Okay, no more than, he can't make it, says right there, no more than 200 balloons. So those are your constraints. So now we have to graph each of those and find the corner points, because we got to get a region like we did here to get those corner points. Okay, so you can refer to the answer key right now and look at the graph. I'm going to remind you of a couple of things. Remember this first one here? That's the vertical line. So that's why that's at the 35. Remember, X is the vertical line. And then you got the horizontal line is 50. And then the X plus Y less than or equal to 20. I would graph that with X and Y intercepts. I probably made this too big. I'm going to shrink it up a little bit. If you use your X and Y intercepts, when X is 0, you can find Y to be 200. And same thing. So you're over here at 200 and this is 200. And then with the shading, we have to be less than 35, less than the, we have to be greater than the 35, greater than the 50, and less than the line. So this is our little region here. So I need to get these 3 ordered pairs. So if you look at this vertical line here, we know X is 35 on each of them. So that I'm just going to fill in. Whoops, not 0. And what's happening right here, we also know the horizontal line, Y is 50. So that ordered pair we've got. This ordered pair here is a little bit trickier with these 2 ordered pairs. Oh, this one we know is on the horizontal line, so we know Y is 50. But in order to get it, we have to find out where does that vertical line intersect the diagonal line. So you're going to take this 35 and plug it into this equation. You know that they have to add up to 200. So that 35 gets plugged in here, and that's where the 165 comes from. And then the same thing here. This 50 gets plugged in here. You solve for X, and you get the 150. So now you have your 3 ordered pairs, just like we did on the example above, and you're going to plug each of those into our constraints, or into our objective function. Sorry, those 3 points are the constraints. And so you take each of those and plug it in. You can see that on the answer key. And we were trying to maximize the profit. So your biggest number is the 765. So your max profit is 765 when we have the 35 and the 165. Okay? Let us know if you have questions by emailing